Hey everyone, welcome back to our channel. Today, we're diving into the mysterious and mind-bending world of black holes. Buckle up, because these 10 crazy facts are going to blow your mind. Imagine a place where gravity is so strong, so utterly dominant, that nothing, not even light, can escape its clutches. That, my friends, is a black hole. We'll be exploring their birth from the death throes of giant stars, their role as architects of galaxies, and even the possibility of them being portals to other dimensions. So get ready for a cosmic adventure. So how do these cosmic monsters come into being? Well, it all starts with a star much more massive than our own sun. Now, stars are like cosmic pressure cookers, fusing hydrogen into helium in their cores and releasing tremendous energy. This outward pressure from the fusion reactions counterbalances the inward pull of gravity, keeping the star stable. But when a massive star runs out of fuel, the outward pressure can no longer hold back the relentless crush of gravity. The star's core collapses in on itself and boom, a supernova explosion blasts the outer layers into space. What's left behind? A region of space-time so dense that nothing can escape its grasp, a black hole. Think of it as the ultimate cosmic vacuum cleaner, sucking in anything that ventures too close. But don't worry, black holes aren't lurking around every corner ready to gobble us up. They're actually quite far away, and their gravitational pull only dominates in their immediate vicinity. Now imagine approaching a black hole. As you get closer and closer, the gravitational pull gets stronger and stronger. Eventually you reach a point of no return, a boundary known as the event horizon. Think of the event horizon as a cosmic trapdoor. Once you cross it, there's no turning back. The gravitational pull becomes so intense that not even light, the fastest thing in the universe, can escape. So, what happens to you if you fall into a black hole? Well, let's just say it wouldn't be pretty, but more on that later. The event horizon isn't a physical boundary like the surface of a planet. It's simply a region in space-time where gravity becomes inescapable. And here's a mind-bending thought. From the outside, we can never actually see anything cross the event horizon. Objects appear to slow down and freeze in time as they approach it. It's like watching a movie that's stuck on pause. Let's say you were to fall into a black hole, feet first. As you approach the singularity at the center, the gravitational pull on your feet would be much stronger than the pull on your head. This difference in gravitational force, known as tidal force, would stretch you out like spaghetti, hence the term spaghettification. As you get stretched further and further, your body would eventually be ripped apart, torn into a stream of atoms spiraling towards the singularity. Now, this might sound like a gruesome way to go, but keep in mind that the extreme forces involved would likely kill you long before you're fully spaghettified. It's important to remember that our understanding of physics breaks down at the singularity. We don't really know what happens to matter once it reaches that point. It's a realm where the laws of physics as we know them cease to apply. Black holes come in a variety of sizes. The smallest ones, called stellar mass black holes, are formed from the collapse of massive stars. They can be a few times the mass of our sun, but squeezed into a region just a few miles across. Then, there are the supermassive black holes, the true behemoths of the cosmos. These gravitational giants lurk at the centers of most galaxies, including our own Milky Way. They can have millions or even billions of times the mass of our sun. To put that into perspective, if our sun were a supermassive black hole, the Earth would be orbiting comfortably inside its event horizon. That's how massive these things are. And there might be even more exotic types of black holes out there, such as intermediate mass black holes, but their existence is still debated. The size of a black hole is directly proportional to its mass. The more massive the black hole, the larger its event horizon and the stronger its gravitational pull. Now, we've talked a lot about black holes, but how do we even know they exist? After all, they're called black holes for a reason. The first evidence for a black hole came in the 1960s with the discovery of a strange object called Cygnus X1. Cygnus X1 is a powerful X-ray source located about 6,000 light-years away in the constellation Cygnus. Astronomers soon realized that Cygnus X1 was part of a binary system, orbiting an unseen companion object. This unseen object was incredibly massive, about 15 times the mass of our sun, yet it emitted no light of its own. The only explanation that fit the observations was a black hole. The intense gravity of the black hole was pulling material away from its companion star, forming a swirling disk of gas and dust known as an accretion disk. As the material in the accretion disk spirals inward, it heats up to millions of degrees, emitting X-rays that we can detect here on Earth. Supermassive black holes, those gravitational giants lurking at the centers of galaxies, play a crucial role in the evolution of galaxies. They act as cosmic engines, driving the growth and evolution of their host galaxies. As gas and dust fall into a supermassive black hole, it releases an enormous amount of energy, often in the form of powerful jets that can extend for thousands of light years. These jets can heat up and push away surrounding gas, regulating star formation in the galaxy. They can also trigger the formation of new stars in other regions of the galaxy. In a sense, supermassive black holes act as galactic architects, shaping the distribution of stars and gas within their host galaxies. They're not just destructive forces, but also creative ones. The relationship between supermassive black holes and their host galaxies is still an active area of research, but it's clear that these cosmic giants play a vital role in the grand cosmic ballet. In the 1970s, physicist Stephen Hawking made a groundbreaking discovery about black holes. He proposed that black holes aren't entirely black after all. According to quantum mechanics, the fabric of space-time is constantly fluctuating, creating pairs of virtual particles and antiparticles. Normally, these pairs annihilate each other almost immediately. However, at the event horizon of a black hole, it's possible for one particle to fall into the black hole, while the other escapes into space. This escaping particle carries away a tiny amount of energy from the black hole. Over vast stretches of time, this process, known as Hawking radiation, can cause a black hole to slowly lose mass and eventually evaporate completely. But don't worry, the evaporation time for a typical black hole is much longer than the current age of the universe, so they're not going to disappear anytime soon. For centuries, black holes were merely theoretical objects, predicted by Einstein's theory of general relativity, but never directly observed. That all changed in 2019 when the Event Horizon Telescope, or EHT, collaboration unveiled the first ever image of a black hole. The EHT is not a single telescope but a network of radio telescopes scattered across the globe, working together to create a virtual telescope the size of Earth. The target of this groundbreaking observation was the supermassive black hole at the center of the galaxy M87, located about 55 million light-years away. The image showed a bright ring of light surrounding a dark central region, the shadow of the black hole. This stunning image provided the most direct evidence yet for the existence of black holes and confirmed many of the predictions of general relativity. It was a testament to the power of human ingenuity and our insatiable curiosity to explore the cosmos. Black holes are often depicted in science fiction as portals to other dimensions or shortcuts through space-time, known as wormholes. While wormholes remain highly speculative, they are theoretically possible within the framework of Einstein's theory of general relativity. Imagine folding a piece of paper in half and poking a hole through both sides. That hole represents a wormhole, connecting two distant points in space-time. In theory, a wormhole could allow us to travel vast distances across the universe or even travel through time. However, there's a catch. Wormholes are incredibly unstable and would likely collapse the instant they form. They would also require exotic matter with negative mass energy density to keep them open, something that has never been observed. So, while wormholes remain an intriguing possibility, they're likely to stay in the realm of science fiction for now. As we've discussed, black holes aren't entirely black. They slowly lose mass over time through Hawking radiation. As a black hole loses mass, its event horizon shrinks, and the rate of Hawking radiation increases. This process continues until the black hole eventually evaporates completely. However, the evaporation time for a typical black hole is incredibly long, much longer than the current age of the universe. So, we're unlikely to witness the evaporation of a black hole anytime soon. The exact details of black hole evaporation are still not fully understood. Some theories suggest that black holes might not evaporate completely, but instead leave behind a small remnant, a Planck-scale object where our current laws of physics break down. The study of black hole evaporation is a fascinating area of research that could provide insights into the fundamental nature of gravity and quantum mechanics. Thanks for watching. If you enjoyed this video, make sure to give it a thumbs up and subscribe for more mind-blowing content. Let us know in the comments which black hole fact surprised you the most. See you next time. Black holes are some of the most fascinating and mysterious objects in the universe. They challenge our understanding of physics and push the boundaries of our imagination. From their birth in the death throes of massive stars to their potential as portals to other dimensions, black holes continue to captivate and inspire us.